So Webassign 15, number 8, we have to find y double prime, the second derivative. So that means you find y prime, and then you take the implicit derivative again. Okay, so and I think the next one you have to find the triple derivative, y triple prime, and then you take the derivative of y double prime, or you take the derivative again. So, and you can do the fourth derivative, but there's tricks to doing this to save you a lot of algebra. Okay, so that's what I'm going to try to go over here, how to do it and save yourself a lot of time by using the tricks. Okay, so here we have this. Again, I have 2s, you might have 3s or something, I don't know. And we want to find this when x equals 0. Okay, so first thing is, we need to know what y is. Okay, they tell us x equals 0. What is y when x equals 0? So you use the original equation. X equals 0, that's 0. So then we just have 2e to the y is equal to 2e. Okay, very clearly, at least in my case, and your case too, because those numbers will probably be the same, y equals 1, right? Y to the 1 power, e to the 1 power is equal to e. So I know y equals 1. So I have the point x equals 0, y equals 1. Okay, so that's the first step, figuring out both points if they don't give you both. Now, we take the derivative as always. So we take the derivative of xy. We have to use a product rule. The derivative of x is 1. So derivative of the first times the second. Derivative of x is 1 times the second. So that's just y. And this is not the answer here. So I'm going to shut this off as soon as I do this. Plus the first, x times the derivative of y, which is y prime, plus the derivative of 2e to the y, which is 2e to the y, times the derivative of what's inside there, what's inside the argument, right? Imagine there's parentheses there. So this is an x, you multiply by the derivative of x, which is 1, but it's a y, so it's a y prime. We get a y prime out of that. Equals the derivative of 2e, e is just a number, 2.71828, goes on forever, so that's just 0. Okay, so let me shut this off. So now is trick number 1 is we want to find y prime at x equals 0, y equals 1 before we move on to the next step. Okay, so before we take the derivative of this again to get y double prime, we want to find y prime because we're going to have a y prime in our final answer for y double prime, and we're going to have to get rid of it. So now we find y prime when x equals 0, y equals 1. So let's plug those in. Y equals 1. I'm going to do this over here so I can keep going with the derivative there. Y equals 1, so we have 1 plus x equals 0. That's nice, that goes away. So then 1 plus this, 2e to the 1, that's just e, times y prime. So 2e times y prime, and that equals 0. Let's see, put the 1 over there. 2e y prime equals negative 1, or y prime is equal to negative 1 over 2e. Okay, if we were just looking for y prime, we'd be done. But we want y double prime. Now, we could solve for y double prime here. Solve for y prime here, and then take the derivative of that to find y double prime. And that's a fine way to do it. Generally, that's more algebra. It's probably not worth the effort. You could, but it's generally better to just take the implicit derivative, again, just the way it's written. Usually works out easier that way. Okay, so let's take the implicit derivative again, not solve for y prime here. Derivative of y is y prime. Here we have a product rule again. Derivative of x is 1 times y prime, so you have another y prime, plus x times the derivative of y prime, which is y double prime, plus, okay, we're going to have a product rule here, the derivative of 2e to the y, which is 2e to the y times y prime, times the y prime that was already there, right? Derivative of the first, which is all this, times the second, plus, I'm going to run out of room, plus the first one, 2e to the y times y prime, right? So derivative, times y double prime. So let's see, let me check this. Derivative of the first, 2e to the y, y prime times the second, y prime, plus the first, 2e to the y, times the derivative of y prime, which is y double prime, and that equals 0. Okay, now, right away, plug in we want y double prime. Here's the second trick. Right away, plug in x equals 0, y equals 1, and y prime equals negative 1 over 2e, and it should save us a lot of algebra. At least the x equals 0 and y equals 1 things will, right? Because those are easy numbers, and we'll get rid of all the things with x's, and y equal 1 is super easy. Okay, so let's do that. Maybe leave the y primes. No, let's plug in the y primes too. Here we have 2 y primes. So that's 2 times that. So I have 2 times negative 1 over 2e. That'll cancel nicely. Plus, that's 0, so that goes away. Here we have 2e. Y is 1, so that's just 2e. Y prime squared, which is y prime is negative 1 over 2e, so that's times negative 1 over 2e squared, plus 2e to the y, which is just 2e, so that's 2e times y double prime, and that's equal to 0. All right, we only have one y double prime here that we need to solve for, but we got to do some algebra with all these. So let's see. Negative, the 2's cancel, so this is negative 1 over e, plus the 2e's cancel. Oh, wait, this is squared. So this makes it positive now. We have a 2e in the bottom, squared, a 2e here. That's going to get rid of one of the 2e's, but we're going to have a 2e left over because it's squared, so I believe that's 1 over 2e. 2e cancels out one of the 2e's, is squared, is positive. Yep, I think that's right. Plus 2e, y double prime equals 0. Let's put these on the other side. So we have, oh wait, let's see if we can do something clever here. Can we do something clever? I don't know. Let's just put those on the other side. So I have 1, the negative becomes positive, so 1 over e minus 1 over 2e. Well, let me put the y prime first. Okay, we have this first. So 2e y double prime is equal to 1 over e plus, sorry, minus. This one's negative becomes positive, that one's positive becomes negative. So minus 1 over 2e. All right. I am going to make this a common denominator because I think that'll make it easier. Okay, let's do that as a common denominator. So this one's got to multiply by 2, so we get 2 on the top. So that's, oh, that's just 2 on the top minus 1. 1 over e minus 1/2. Well, yeah, okay, that's just 1 over e, right? 2 over e minus 2 over 2e minus 1 over 2e, 1 over 2e. Okay, I better do my work completely to make sure of that. This is 2 over 2e, 2 over 2e minus 1 over 2e. So yeah, that's just 1 over 2e. All right, so 2e y double prime equals 1 over 2e, or y double prime is equal to 1 over 4e squared. Divide both sides by 2e. I have 2e times 2e. So I get 1 over 4e squared. Cool. So the second derivative is 1 over 4e squared. That's how fast the first derivative changes. The third derivative would be 0, right? Because this is a constant. So if we had to find y triple prime here, we know right away it would be 0, because y double prime is a constant. If our y double prime had some y's and y primes and stuff in it, we'd have to take the derivative again implicitly and go on. But we don't, because turns out, wait, sorry, that's not right. That's not right what I was saying. Because here, y prime, okay, sorry, that's not right. You got to be careful. I wasn't being careful. This is y double prime at that point. It's not always 0. It's that number. It's not always that number. It's that number at the point. Just like here, it's the slope at the point 0, 1, it's that slope. That's the y prime. Here's y double prime at that point. Y triple prime is not always 0. Sorry, it's only 0 at that point. Sorry, I can't even say that. To find y triple prime, You gotta be careful. To find y triple prime, we would have to take the derivative of this thing again. Okay, before we plug in the numbers, we have to take the derivative of this thing again. We'd get a y triple prime every time we take the derivative of the y double prime. And then we can find y triple prime, then we plug in the numbers. Okay, you gotta be careful of that. So the next one, I believe that's what you have to do. You find y double prime, just like we did here. Then you take the derivative of the thing again, plug this in for y double prime, plug in the answer for y prime, and you can find y triple prime. Hopefully I don't get you too confused with that. So, yeah. Okay, so the whole rule, let me go over this again. The rule to make these things simpler is just take the derivative implicitly, right away plug in the points, and then solve for the first derivative, get an answer. Then take the original equation before you plugged in the points, take the derivative of this, that's this, take the derivative again. Now plug in the points, solve for y double prime, get an answer like we did. And if we had to take the third derivative, we'd take the derivative of that one again, plug in both these points, this and that, to find y triple prime at that point. Okay, phew, good. Thank you for listening. Goodbye.